Today's notes are over piecewise functions. So yesterday, whenever you started that absolutely in pieces paper, it is an introduction to piecewise functions, which is what we're going to be doing today. So the definition of a piecewise function is a function that uses different formulas which formulas is the same thing as equations for different x values. So a function that uses different formulas or equations for different values of x. Okay, and the notation. So if I have a piecewise for f of x, you do the squiggle bracket on the left side, and then you're going to have your first equation written out, and then we'll do a comma, and then list out an interval. And then same thing, you'll have your second equation, and then another interval. So this interval is going to notate something like x is less than a number, or it could be like x is greater than a number, or it could be a double inequality, like x has to be between two certain numbers. Okay, moving on to part 1. So given the graph below, write a piecewise equation to fit the function. So here's our piecewise graph, and we're going to actually write an equation out to represent this. So I'm going to use 3 different colors. Let's start with this graph that I'm highlighting in purple. Okay, so remember that we need to use y equals mx plus b whenever we're writing a equation for a linear graph. So we need to figure out what the slope of this is. Well, it looks like it's going up 1 over 1, so it'd be positive 1 for the slope, and then the y-intercept is right here at positive 5. So this would be y equals x plus 5. So that's my first equation, and then we need to specify an interval for which this graph is being used. So we're only using this graph for when my x's are less than 0. Because see, right here is when the graph starts, and then it just keeps going more into the negative side. So I only use this graph whenever my x's are less than 0. And you could do less than or equal to. Okay, moving on to the next one. So now I'm going to use just this horizontal graph. So this one's just a straight line that goes through y equals 5. So the slope is 0. And then this is an example of when you would do a double inequality, because it starts here at 0, but then it ends at positive 3 on the x-axis. So I would go between 0 to 3, and it could equal 0, but it could not equal 3. Because notice there's that open circle over x equals 3. And last one. So this graph has a slope of up 2 over 1. So it'd be y equals 2x. And then we don't know what the y-intercept is, but if you extended out this graph and kept going, down 2 over 1, down 2 over 1, it would cross at -6. So anytime that you can't actually see the y-intercept, just keep following that slope out until it does cross the y-axis. So this would be 2x minus 6 for the equation. And then we need to specify the interval. So this graph starts at when x is at 4, and then all of your x values are just increasing to the right. So this would be when x is greater than or equal to 4. So now that we have these equations for each graph, we need to write this in the correct piecewise format. So I'm going to write f of x equals, and then this curly bracket. And then you don't actually have to write y equals each time. You can just write the equation. So for the first graph, I would have x plus 5, comma, and then list out that inequality when x is less than or equal to 0. So just like what we did with that paper yesterday and absolutely in pieces, we're doing the same thing. And then the second graph was y equals 5. So like I said, don't write y equals, just write the equation. And that was whenever x was between 0 and 3. And then finally, for the third graph, my equation was 2x minus 6 when x was greater than or equal to 4. And that's it. So that would be your piecewise function that would represent this graph. Whenever you do your homework, just like what we did yesterday, you don't have to worry about doing like less than or equal to or greater than or equal to. Just use the less than or greater than signs on your keyboard, and then that way it'll be a little bit easier so you don't have to go find those symbols. Okay, let's move on to part 2. On this part, we're going to be evaluating a piecewise function. So they gave us this function, f of x equals 2x plus 4 when x is between 0 and 6, and then 3x squared minus 1 when x is greater than or equal to 6. So I'm going to use two different colors again. I'm going to use purple for the first one and green for the second. So if I want to find f of 0, I have to figure out what interval does 0 fit into. So let's look at these intervals. So 0 would be between 0 and 6, because this inequality says that x is greater than or equal to 0 or less than 6. So 0 fits between those two inequalities. So I'm going to plug it into this first equation. So I'd have 2 times x plus 4, and my x equals 0. So I'm going to put 0 in place of x. 2 times 0 is 0, and then plus 4 would just be 4. Okay, now we're going to find f of 4. So once again, 4 fits between 0 and 6, so I'm going to use this first equation again. So I'd have 2 times 4 plus 4. 2 times 4 is 8, and 8 plus 4 is 12. Now moving on to f of 6. So be careful here, because you might think, well, 6 fits between 0 and 6, but it's not equal to. It's just less than 6. So we have to go to the next equation, because this interval says x is greater than or equal to 6. So we would have to use the 3x squared minus 1 equation. So I'm going to plug in 6 for x. So 6 squared is 36, and then 36 times 3 is 108, and then 108 minus 1 would be 107. And then the last one, find f of -2. So looking at both of these inequalities, -2 does not fit into either one of them because it's not between 0 and 6 and it's not greater than 6. So when this happens, we just say that it's undefined because it doesn't fit within the intervals that were given for each inequality or for each equation. All right, last example, part 3. So this time we're given a function and we're going to graph it. So you can actually type this in your calculator if you wanted to, or you can do it by hand. If you want to do it on your calculator, you have to hit the button right next to 9 and then go to the option that looks like this. And then you can actually type it in just like this. So you would put in absolute value of x minus 2, and then you would type in this whole inequality. In order to get the inequalities, if you'll hit Control Enter, or Control equal sign, I believe, and it will pull up your inequalities for you. So that's how you do it on a calculator. And if y'all need help, just let me know, and I can always post a video of how to do that. But I'm going to show you how to do this by hand as well. So let's start with this very first equation, which I am circling in pink. And they give us this inequality from -4 to -1. So I'm going to create a table with those points for my x values. So -4, -3, -2, and -1. Because for this first graph, it has to stay within those 4 numbers. So if I plug -4 into this equation, I would have the absolute value of -4 minus 2. So -4 minus 2 is -6, but it's the absolute value, so it'd actually be +6. Then I'm going to plug in -3 into the equation. -3 minus 2 is -5, but its absolute value should be +5. Okay, and then if we kept going, we could just follow this pattern, and then we would get 4 and 3 for the next 2 numbers. So let's go ahead and plot those points. Just be careful on this last point, -1, 3. This is an open circle because of this inequality here. It's just less than -1. It can't actually equal it. So I'm going to plot those 4 points. And then on -1, 3, I'm going to leave it as an open circle. Okay, now let's do the next equation. So these numbers, or these x values, start at -1 and go all the way to +3. So if I plug -1 into the second equation, it's x plus 1, so I'm going to plug in -1. So -1 plus 1 is 0. And then I could plug in 0, so 0 plus 1 is 1. And then 1 plus 1 is 2. 2 plus 1 is 3, and then 4. So once again, this last point is open because if you'll look at the end of this inequality, it's just less than 3. It's not equal to 3. So let's go ahead and plot those 5 points. Okay, and then finally we have this third equation. And this one's pretty easy because all of my y values equal -4. So for every x that's greater than 3, not equal to 3, but greater than 3, we just have a horizontal line that equals -4. So right here at +3, I'm going to have an open circle at 3, -4, and then it's just going to extend all the way to infinity on that horizontal line of y equals -4. So if you did want to have a table, it would look like this. So as my x's got bigger than -3, all of the y's would equal -4. All right, that's it for your notes. If you have any questions on your homework, let me know. Have a great day.